Hey everybody, let's go over the short answer questions. Actually, it's just one of the questions. Question number 2 from exam 3, where I ask you to balance a redox reaction that's in basic solution. Now, you wouldn't probably need to know that it was in basic solution because it says there's hydroxides and stuff going on. Hydroxide is definitely key, the key thing to look for. When you're doing these things to determine that it's in basic solution. But let's take a look here anyways. We're going to break this into its half reactions. So we're going to get one half reaction that's FeOH3 reacts to form FeOH2. Okay, and then we're going to get this one, chromium, goes to chromium 3 hydroxide, CrOH3. Now to balance this, we're going to first balance the non-hydrogen and oxygen atoms, balanced. Okay, and then we're going to balance the oxygens using water. So here's 3 oxygens, and here's 2, so we need plus 1 H2O on this side. Okay, and now we're going to balance the hydrogens with H plus. Okay, and so now we have an O and an H, and so if we count, we have 4 hydrogens here and 3 hydrogens here, so we need 1 H plus. And now the difference between between acid catalyzed and base catalyzed is acid catalyzed. Once we get it all balanced, then we have to add hydroxide. So we're gonna add the electrons now. So the electrons, let's see, I'll do that in green. So this is going to be 0, and this is a 1 plus. So that means I need 1 electron over here. Okay, and now I'm going to, in red, make this a base catalyzed reaction. Now that everything is balanced, everything in this half reaction is balanced the way it should be, okay, what I'm going to do is I'm going to add hydroxide here, and that combines to give me 1 H2O. And then if I add it to one side, I have to add it to the other side. Okay. Now the neat part about that is if we have H2O and H2O, look, 1 H2O on one side, 1 H2O on the other side, these cancel out. Okay, so now we do the same thing down here. So we look at the non-hydrogen and oxygen atoms. That's this. Okay, and now we have to balance the oxygens. Okay, the chromiums are already balanced. So this is going to give us 3H2O. So now we balance the hydrogens. This is 6, and this is 3. So this is going to be plus 3H plus. And now we're going to put in electrons. So again, I'll pull out the green. And so this is 0, and this is 3 plus. So now we need to do 3 electrons on this side. Excuse me. Now that it's balanced, in red, we have 3H plus, so we're going to do 3OH minus. So this cancels this out to give us 3H2O, but now we need 3OH minus on this side. What we add to one side, we add to the other. It's already balanced, so that's where that comes in. But look, 3H2O, 3H2O. Okay, great. So now, what we need to do is make sure that the number of electrons here balances out. So we have to take this whole reaction and multiply it by 3. That way we have 3 electrons and 3 electrons balanced out. So now what I do is I take and I add up both sides. I'm like, okay, so this is canceled out. So now I have FeOH3, whoops, plus 3OH minus plus Cr reacts to form, this should be a 3, right? Because of the 3, plus 3FeOH2 plus 3OH minus plus CrOH3. C's around that. Okay? Now look, we can get rid of these and cancel that out. So now everything should be balanced. Okay? Because these cancel out. Okay, so now for question number 2, we're going to do the same process. It seems like same thing over and over again. So it's Ag2O reacts to form Ag, and then that's hydrazine. It's a rocket fuel. N2, so we're going to balance. So now we actually have to balance the non-hydrogen and oxygen atoms. Plus H2O, because I needed oxygen. Now we balance the hydrogens, plus 2H plus, and now we need the electrons. So that's 0. This is 2 plus, so we're going to do plus 2 electrons. Now we can go and add 2 hydroxides here to get rid of that to make 2 waters. But because we added 2 hydroxides here, when it was already balanced, we're going to do 2 hydroxides here. Now, we balance the nitrogens. Nitrogens are balanced, so now we go to the oxygens. Oxygens are balanced, so now we're going to do hydrogen ions, and notice we're going to need 4 of those, and then we're going to have to look at the charges and charge balance. So this is 0 on this side, this is 4 plus, so we need to do 4 electrons on this side. Now, I'm going to add 4OH minus to both sides because it's already balanced, and so this is going to go to 4H2O. Okay, so now we're going to look and see what we have to do to cancel out the electrons. This guy gets multiplied by 2. 2 times 2 is 4. That's 4 electrons. This is 4 electrons. So now the electrons are canceled out. So now we can take and combine the reaction. So we're going to take everything that's on the reactant side. So I see 4H2O, right? 4H2O plus 2AgO, Ag2O, plus, now down here is 4OH minus, plus N2H4, reacts to form 4Ag plus 2H2O plus 4OH minus plus N2 plus 4H2O. Okay, so now we can do a little bit of balancing, or a little bit of combining like terms. And so we get rid of 4 hydroxides and 4 hydroxides, and then we have 4H2O and 4H2O. Notice these two are going to stay there. So the overall reaction, and I know that I'm pushing into question 3 here, but okay, is going to be 2Ag2O plus hydrazine N2H4 reacts to form 4Ag plus 2H2O plus N2. So, phew, all of those, that's how you balance reactions in base catalyzed oxidation reduction reactions. Hope you got close to those right answers, and have a great day.